So clearly there were a lot of problems with the choices that that the fellow made when he collected the data and saved the data. And we don't want you to do those things. So what went wrong? Well, first of all, there was a problem even finding the data, right? Because it was on a USB key in an unlabeled box. The next difficulty was accessing the data. It was in a proprietary weirdo format that could only be read by special software that was not available easily. And then still, even when the data was accessed, there was another problem. It was impossible to interoperate with the data because the variable names were idiosyncratic and there was no documentation of the vocabulary used to label those variables. Ultimately, the data was not reusable. So that video was made in 2012, and we've come a long way since then. But the problems have not gone away. So consider the retracted COVID-19 study on chloroquine from May 22nd, 2020. It was not retracted because it was wrong. It was retracted because the data was not shared. No one was sure what hospitals participated, and no one could independently verify the results. So these are the principles. These are named principles that people refer to a lot now, these FAIR principles: findable, accessible, interoperable, reusable data. You want to be able to find the data, the original data, not the article that was generated from it. You want to be able to look at the data. You want to be able to understand the data, and you want the data to be reusable. So in 2016, these FAIR guiding principles were first published. And they proposed making data and code, that is scripts and programs like the scripts you wrote the other day, first-class citizens. That means that the data and the code, not just articles produced from them, could be published with a unique identifier, the DOI, data object identifier, I think. So data and code could then be stored in online repositories and reused. And you would credit the authors who wrote the stuff. And to take it one step further, researchers are developing standardized vocabularies in different fields. These are called ontologies, standard ontologies. And these vocabularies include relationships between concepts. They differ by area of study, but things like group classification. And if you use these vocabularies, you greatly improve the usefulness of your research. So even in brain research, you would think that when we do brain research, that there would be a bunch of standardly labeled areas of the brain that people would refer to, but you'd be wrong. You'd find that there were, 3 or 4 or 5 different terms for the same part of the brain, and that then when you looked at exactly what was incorporated into any one of those definitions, sometimes those areas overlapped completely, and sometimes they overlap partially. So there's all these different vocabularies, even in an area like brain anatomy. So one thing you need to do to really to share and reuse data is for people to agree on these vocabularies at some level. So if you have these rigorous ontologies, then the prospect of using computers to explore the data automatically, to read articles, and to look for patterns in and across data sets and articles, that becomes possible because people are starting to use the same terms to refer to things, and it's getting more and more consistent. So these are all things that have come about since 2016, these ideas, and they're not fully implemented yet by any means, but it's a goal. It's where we want to go.